Thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. First of all, I'd like to thank the organizers of this conference for inviting me here in Lisbon. It's always a pleasure to be here. I love the city, the country, the people. And, well, the opportunity is to talk about asphalt rubber mixtures and materials, which is one of the areas of specialty of my research group and in the last, I would say, 10 years. Brief outline of my presentation. I will spend a few words on my institution, the Politecnico di Torino, and talk briefly about my pavement engineering research group. Then I will try to put the subject of Crumb rubber-related technologies in perspective by showing what is the state of implementation in Italy. What are the problems we had to face in the past and we are still facing. And from that, I will move to a series of what I think are unsolved dilemmas, areas of knowledge which should be further investigated, therefore highlighting some of the most relevant research needs. And then I will show you, by following our research approach, which was the one we adopted in the Politecnico, some hopefully interesting results, which will touch upon several of the topics which have been mentioned by the previous speakers. I will also highlight some doubts. I think that doubts are important because they lead us to a better understanding of phenomena. And finally, I'll try to close up with future perspectives. Okay, so just a few words on my institution, the Politecnico di Torino. It is I would say, one of the leading technical universities in our country. It was founded 1859. It has a quite large student population with an international flair. We have campuses in China, in Turkey, in Uzbekistan. And nowadays, it is organized as a pretty much research-oriented university. My group, it's a group composed by young people, enthusiastic. We focus on bituminous materials and pavements. Our laboratory, which is the core of our activities, is obviously focusing on bituminous materials, but more in general on innovative and recycled materials. So I think this fits perfectly with the subject of green pavements. And finally, we provide a number of services, including, of course, testing services and specialized training. We have this international attitude. Currently, we're hosting Professor Underwood from Arizona State University. He's in the audience. He'll give a presentation in the afternoon. And of course, we have several exchange programs going on. Just to give you an idea of the type of activity we carry out, it has changed in time, starting from the 60s to nowadays. And if you look at the red portion of those cakes, you can see that progressively our lab and our group has shifted from, let's say, testing and quality assurance services to a core of research activities and projects. So getting to crumb rubber related technologies, what is the situation in Italy? Well, I think we should just observe that there is a widespread establishment of end-of-life tire grinding plants all over the country. And what is this crumb rubber which is used for? Well, a lot for energy production, unfortunately. So George will get angry now, but this is this situation. Some of it for recycling. And of course, as pavement guys, we would really support the idea of using these materials in pavements. However, there is one constraint, pretty much a local constraint, which is that of a single asphalt rubber supplier in Italy. Now, this makes things quite complicated because this is a true obstacle in attributing works, actually construction works, if there is a single supplier. So we need some kind of competition to get the things going, of course. Nevertheless, there has been some experience, a lot of experience on gap-graded and open-graded mixtures for local and provincial roads, and eventually there has been some increase in that, some experience on stress-absorbing membrane interlayers. There is, I think, the need of expanding the realm of possibilities, and recently we've worked quite a bit on dense graded mixtures and on hybrid mixtures with low temperature applications and low viscosity additives. Now, of course, there is also an interest for the terminal blend production. This is something different. There has been some attempt in refineries. Currently, we're looking at a project in Torino for the possible production of terminal blend products. And finally, there is a growing interest for dry mixtures. Now, dry mixtures, to me, are fascinating because they are complex. We have a problem with the uncontrolled interaction between the crumb and bitumen, and we end up very frequently with lean mixtures which are not so durable, which are prone to raveling. So there are some tricks that can be used to make this better, and this has been part also of a European project we had in which we designed and built a full-scale mixing prototype for the production of dry mixtures. And the constraints for implementation following this scenario are that of a limited direct experience and information. Even though the number of applications is increasing, for administrations, the numbers and the quantities are still small. Okay, this is in the numbers. So we really need to put an extra effort in disseminating knowledge, in showing our results, in lobbying, if the case. As a professor, of course, I can do part of the research and do it rigorously and show that it works if it does. And there is an absence of technical specifications. This is another constraint. If these materials are not in technical specifications, regardless of their good reputation, there is a formal problem. So we need to get these materials in technical specifications. So maybe in part answering to I don't remember which session was that, but anyway, one of the questions that were asked by George, we need technical specifications because this is the engineering way to do it. I don't know if the escort service is implied in technical specifications. So as I mentioned, we need a wider commercial competition, and we need to answer to unsolved dilemmas. So any professor would conclude more research is needed. Okay, we're happy with that. Okay, what about the unsolved dilemmas? I tried here to highlight some. I understand this may be a little bit technical, but I'll try to arise some interest in these bullet points. First thing, we do know that there are interactions between the components of an asphalt rubber mixture. Interactions going on between bitumen, crumb rubber, and aggregate. Whether it is a wet produced material, it's a asphalt rubber per se, or a dry application. There are interactions going on, and we need to fully understand those interactions because they will affect performance. Okay, and anytime we lose one piece of information, this is absolutely detrimental for the proposition of any technology. And within this scenario, we need to identify the effects of several factors. Not only we have a threesome of subjects which are interacting, but we have external factors which may influence this interaction. And of course, this has to go in technical specifications. My dream is that crumb rubber should be certified. At a certain point in our activities, we introduced a crumb rubber certification system for paving applications. And I think this would add value to the product. I don't know if we can send it at a very high price, as Camille suggested, but we could give its true potential value through testing. Then, of course, we still have a number of unsolved dilemmas related to performance. We know that mixtures containing crumb rubber have potentially a very high performance, but we need to show it, and we need to show it with performance-related testing, such as rutting tests and crack propagation tests. There's a lot which has been done in literature, in the world of research, but we need to disseminate this knowledge. And we also need to have some full-scale monitoring, because at the end of the day, when we go to administrations and show them laboratory results, they will want to also see hard data coming from full-scale monitoring. Okay, so research projects should also include these experiences. And to me, it is also important to expand, as I mentioned, the array of possible mixtures, ranging from dense to gap-graded and all the intermediate possibilities, combining standard and non-standard aggregates with this kind of binder, and once again leading to technical specifications. On a different level, we have issues related to health risks and life cycle assessment. So something which has to do more with the social and environmental components of the overall sustainable pavement. Now, with respect to health risks, now one of the topics which have been debated quite a while is that asphalt rubber can be really bad for workers' health. And this derives just from one problem, the smell, okay? But does this imply that it is bad? Now, we cannot just answer no with no information. We need to investigate. And we've done this quite a while, looking at the gaseous emissions which are produced on site. We did a lot of sampling, of laboratory testing. In the laboratory, we simulated possible emissions, and we always compared the results obtained to standard mixtures. Per se, gaseous emissions are not good. Any kind of asphalt-related application, okay? That's not what you would want in a spot. But obviously, when you compare asphalt rubber products to standard products, you may see a small difference. And in fact, in our experience, the difference is small. And this can be sustained by the modeling of the toxic and carcinogenic effects. Once we have this data, we can then go to administrations and say, look at these data, these show that there is an equivalency in these two kinds of applications. Okay? So it is very important. And finally, going back to one of the topics which was touched upon both by Camille and Georges, we have to look at the general application of asphalt rubber products in a life cycle framework. We have to look at these materials in a cradle-to-grave perspective, looking at the equivalent CO2 emissions, looking at energy consumption, and we can do this with several approaches. We've done some work on this, once again, by adopting a differential assessment. We want to compare standard solutions to solutions which entail the use of asphalt rubber. Okay, so I've put a lot of slides in my presentation, and I understand I will have to skip some of those. We're already running late, but you'll have them available from the organizers. And so they describe quite a bit what we've done, several examples of what we've done. Just to give you some information on the approach, we moved from the local to the international scale with several projects, either local, city, provincial projects, national, European, and in each and every case we adopted a multidisciplinary approach, combining the know-how and experience coming from the pavement engineering group and from the sanitary environmental engineering group. So we are two groups in the Polytechnico working very closely, and when doing this we work at a multi-level, with a multi-level structure, moving from crumb rubber characterization to the analysis of crumb rubber bitumen interactions, which could be asphalt rubber, or it could be the mortar, which is formed within a dry mixture. We do a lot of laboratory testing for performance predictions, and then of course we have field testing, which include technology development. So I'll try to be synthetic in the illustration of some of these results. Starting from crumb rubber characterization, in literature there are some requirements for acceptance. And regardless of the treatment process, there are constraints which are related to maximum particle size, density, cleanliness, and moisture. Very basic. They are listed in ASTM 6114. This is the current approach, but it really does not tell you the true value of a crumb rubber product. So first of all, what we need to do is to organize the information, the standard information, in a better way. One good example is that of particle size distribution. We sampled, I think, at least 20, 25 different products, and all of them were sold or available for asphalt rubber production. And we found out that there was a huge difference in particle size distribution, not only with respect to ASTM standards, but in absolute terms. So we suggested the formalization of 3 different categories: the coarse, standard, and fine gradation. in order to tailor different applications for different end properties. What about density? This is a histogram of different densities obtained. We observe that the densities are comprised within quite a narrow range. Of course, it's rubber, and from one tire to the other, the variations in terms of density are limited. Nevertheless, density is important if you want to make some prediction on surface area. So let's keep it as a good requirement. What about cleanliness? Well, cleanliness has to be looked into. We do this usually by microscopical observation. In general, we observe that there is a visible presence of impurities, metal impurities in finer products. So this should be looked at with care. And one very important thing is morphology. What is the ideal shape of crumb rubber? Do we want to have stretched and corrugated particles or more compact, let's say, round or polyedric particles? Well, depending on the kind of interaction we desire, we may have different requirements, but we need to put a number to that. So very simply, we do some microscopic observation combined with image analysis. We convert particles into objects which have physical quantities, and for these quantities, we can make such a modeling which allows us to calculate surface area, a true surface area which takes into account the degree of elongation and the surface irregularities of the particles. Now, there's a little bit of mathematics in this, and it may seem complicated. It's not. It's very straightforward. We're basically changing the model from a model made of smooth balls to smooth rugby balls or footballs to a regular and textured rugby ball. And this is done by just using multiplications, sums, and divisions, which are more or less the only maths I remember at this point in my career. Okay, so coming to bitumen crumb rubber interactions. What about these? Well, we do know that there is a time-dependent interaction going on, which starts from mixing and goes through a swelling phase, and it leads to depolymerization at a certain point, and eventually it can lead to digestion. And we know that these phases are, well, the time scale of these phases and their extent is affected by several factors, which they are listed there: the type of base bitumen, the properties of crumb rubber, the presence of additives, and several mixing variables such as temperature, time, and shearing forces. So we need to all take them into account. And this is important because depending upon how this process evolves, the product will be different. Now, this is a very good figure of viscosity tests in which for a certain crumb rubber, we see that as a function of curing time, viscosity peaks and then degrades. We know about this, okay? But what we've done is to introduce two numerical parameters, a swelling rate and a degradation rate, which simply are the slopes of the upper and the down curve of this graph. And these will synthesize the time-dependent interaction of bitumen with crumb rubber. So to me, ideally, in a spec, any producer of asphalt rubber should give information on this, because when we produce asphalt rubber, we want our material to be very close to this peak. Okay? Usually, the assumption is that it should be produced to be slightly green, not totally ripe. Okay? So we want to be very close to the peak. And in order to be there, we need to have information on the swelling rate and degradation rate of our product. And this, of course, if we do not have this information, we may produce different binders with the same base binder and different crumb rubber products and obtain viscosity curves which are completely different. Now, this means that either the crumb rubbers are really different or they have been sampled and stopped in production at a different point in their evolution. So this really shows that you can get any number from viscosity if you don't control those two factors I'm talking about. And of course, this also reflects on rheology. We do a lot of rheological testing in producing master curves of the complex modulus, of the phase angle, we can do a lot we can get a lot of information from these data and relate them to performance, but this needs to be related to production conditions. If not, these are just numbers. They are of no use. This is quite interesting. What about fatigue? Okay, this is quite nice. These are repeated time sweep tests carried out on a base bitumen and on different blends obtained with increasing quantities of crumb rubber. Does fatigue life increase? Yes, it clearly does. And this is also shown by my mixture testing. Okay. What about resistance to rutting? Once again, we have very good results here. Okay. If you look at this asphalt rubber product, this is the non-recoverable creep compliance, let's say deformability, permanent deformability. Very small when compared to a polymer modified binder, let's say high polymer content. Polymer modified binder with low polymer content, neat bitumen. Okay, this is really impressive. Okay, so if I go up to some engineer or in an administration, he'll say, okay, I like these data, but I want to see also mixture data. And now we have a problem here, because when we move to mixture data in the laboratory, we may end up with results of this kind. This curve here is a dense graded standard mixture. These two lines up here are of two gap graded asphalt rubber mixtures. And this is the proportional rub depth. What do these figures tell you? Well, that you're having a greater accumulation of deformation in your asphalt rubber mixtures. So what is going on? Is there anything wrong in this? Well, is it bad performance or is it ineffectiveness of testing protocols? And I guarantee that the right answer is the second one. We need to use the right protocols to prove, to investigate in comparative terms the performance-related potential of a material. Now, the problem here is that in wheel tracking tests, we have no lateral restraint, and with non-continuous grading curves, this will be really penalizing. Okay, so we cannot go with this kind of testing, or we can use it, but then we need to twiggle around with the data, and this, I don't think it's the right way to do it. So we can approach this with different pieces of equipment, such as the asphalt mixture performance tester. In that case, we will need to apply a confining pressure. But really, this is, I think, a good example of what could be a wrong conclusion if just presented in very simple terms. Look at the numbers, and you get a wrong conclusion. So we need to really be careful. And similar observations should be done on crab propagation. Okay, we want our material to have a very high toughness, and this will occur with the presence of rubber, but we need to choose the right configuration, and in particular, we need to choose the right notch depth in order to highlight the true effects of rubber. If not, we have the same risks which I just showed you in the case of permanent deformation. Some words on part of the activities which we developed in technological development. Okay, so as part of a European project, the TireRec for Life project, we worked on the construction, on the design and construction of a full-scale dry mixing prototype. And the idea was to have a prototype which would be very flexibly used with different types of crumb rubber, with different quantities, and allowing crumb rubber to be used both in hot and in cold conditions. And we had a base plant which needed to be modified. We opted for the use of a double drum which needed to be introduced in the plant, and we had the possibility of having two different crumb rubber feeders with a conveyor belt. And the idea was to introduce the crumb rubber not too close to the burner, and by employing a double drum. And in the double drum, the crumb rubber which is used is in the space between the two drums and is not overheated and therefore is not consumed before being mixed. So this is the double drum being delivered to the plant, and then there was some assembling going on, and we did some initial calibration, and then we had some full-scale trials. Okay, full-scale trials in which we tried crumb rubber in the dry application, both an ultra-fine and a coarse crumb rubber, and we tried it both in the wearing course and in the base course in different combinations. and then we monitored the traffic to which these cross-sections were subjected to. And now we are working on the data, and they are quite interesting. One of the greatest issues is, of course, compaction. So you need to be very careful in adopting special care in compaction. This is the first problem. The second problem is mixing time. Okay, we saw that depending on the type of crumb rubber, these may be quite sensitive to mixing time. So there is some need for experience in this area. Now, very quickly going to other topics, and of course we do a lot of field inspections in our projects, and then we go back to the lab and do some testing. We have one very simple problem which I think should be solved. What is the quantity of asphalt rubber in a mixture? Okay, in a performance-related approach, we don't care, but of course we need to control for financial reasons. Okay, we want to be sure that all the bitumen, all the asphalt which was designed is there. And if we use the solvent extraction method, we are not able to separate crumb rubber from the aggregate. If we use the ignition method, there is some unburnt material. So in both cases, we have an underestimate of asphalt rubber dosage. We can calibrate it, of course, we can do some calibrations, but this is one big problem, because if an administration does not have a tool, a simple tool, to control asphalt rubber dosage, it is one problem. Okay? Another example, I don't have a slide, unfortunately. What about the quantity of crumb rubber in asphalt rubber? Can you look at that? Once again, you could say, who cares? I'll just look at the properties of the binder. Well, for financial reasons, once again, I may want to check what is the quantity of crumb rubber in a binder. Can you do that? Well, it's not easy. We've come up with a combination of thermal and chemical analyses. I forgot to put it in the slides, but I have a paper on that. If you're interested, I can provide you with some information. So these are problems which have a reflection on the diffusion of these technologies. Okay, so I'm not the psychiatrist for today, but maybe there are some of the answers are in these small details. What about safety-related problems? Well, of course, we need to look at this in full-scale sections. We've done this with one administration close to our city, and we compared gap-graded and open-graded asphalt rubber courses with a porous asphalt. And we looked, of course, at macro texture and at skid resistance, and we followed through in time. Now, there is, of course, some variation due to in time, due to the wear, which is operated by tires, but we are following through on these sections to have a long-term monitoring of these applications. What about noise? Noise is another issue. Well, the approach we adopted with the Fiat group, now Chrysler Fiat group, was to use an instrumented vehicle, and this vehicle has microphones both in the vehicle and close to the tire pavement contact, and we employ the coast down procedure, which means that the vehicle approaches the section at a certain speed, then there is no motor anymore, it's turned off, and we just have the rolling noise. And in the cabin, we have, with the use of rubberized materials, we have a decrease of 3 to 4 decibels. And for the external microphones, we have a reduction of 5 to 6 decibels. Now, this is very interesting because it's just rolling noise. Okay? And that is where you're getting the greatest contribution from a very flexible interface, such as that which is created by rubber. Okay? So, and we've published these results in a conference in Korea. Finally, getting to let's say more environmental or social aspects. I mentioned of the need of monitoring gaseous emissions. We have our own procedures. We've applied this to many construction works. We sample gaseous emissions at the driver's seat and at the screed. We do this in the most stringent conditions, and that is when the hot mixture is discharged from the truck to the paving machine. And there is a given procedure for sampling and for analysis in the laboratory. What we focus on typically are the VOCs, the volatile organic compounds, and the PAHs, the I forget, hydrocarbons. No, I forget the name. And these basically are those compounds which may have toxic and carcinogenic effects. They may have, okay? Well, of course, carcinogenic effects are related to a given rate, okay, to a given slope. Toxic, they are such if they are above a certain threshold. Nevertheless, we need to monitor them. And here you have an idea of how things changed in different laying sites. And of course, when you compare one data point to the other, what is changing is composition, wind conditions, temperatures, quantity of binder, type of crumb rubber, a lot of variation. Nevertheless, if you take out spurious biasing points, you have that those numbers tend to move in a very narrow range. And within this range, you also have those sites in which you have standard mixtures. So overall, the impact is if you look at it at a global scale, is quite good. If you want to have more detailed investigations, you can go to the laboratory scale and simulate gaseous emissions in the lab. We set up our own equipment. And here you have a comparison between gaseous emissions in a laboratory test and in field sampling, okay? And this is the equality line. You have some dispersion, but on the big numbers, in the lab, we simulate quite well what is going on in the field. And eventually, we can use these data to be fed in the modeling of toxic and carcinogenic effects. So we start from the site assessment. We need to have a conceptual model and a diffusion model. And eventually, we come up with the risk calculation. So we need to calculate the dose of the compound to which the worker is exposed, the corresponding toxicological risk, and if the material is carcinogenic, the potential carcinogenic risk. And once you do those calculations, you can perform them in different conditions by looking at the experimental data from the driver at the screed, comparing different solutions. Here we have ratios, wet to standard, dry to standard. Now these numbers, okay, are all very close to 1. In this very global evaluation, 1.2 is no different from 0.89, okay? There are changes when you have orders of magnitude of change in terms of the ratio. So really what you conclude from here is that there is almost an equivalency between the exposure, either toxic or carcinogenic, for rubberized and non-rubberized materials. Finally, last point of the possible menu of activities we've been developing is related to life cycle risk assessment. And life cycle risk assessment, of course, is based on what are the energy consumptions and the CO2 releases which are connected to each phase of the pavement construction. And here we have the comparison between a standard and an asphalt rubber wet solution. On the left side, we have the GER, which is the gross energy requirement, so total consumption of energy. On the right-hand side, we have the GWP, which is the global warming potential, expressed in equivalent kilograms of CO2. And you can see, just by comparing the two scenarios, that you have a reduction of the energy consumption by adopting a rubberized solution, and also a reduction of the potential global warming potential. Benefits are of the order of 20% in this specific study. This is based on true data of a true section which was built within the European project. And same thing can be done by comparing standard to dry. And in this case, nevertheless, we see that there is a limited difference. So we can see that there are no relevant differences, at least for this specific case study. And the reason is that at the time we performed this study, we did not have sufficient data to suggest that layer thicknesses could be reduced as a presence of crumb in the dry form within the mixtures. Once we increase our knowledge on those mixtures, perhaps this comparison can change its result. So last slide on future perspectives. Of course, it is difficult to draw conclusions. There are no conclusions here. It's work in progress. So really what I think I can wrap up my presentation is just a vision of what can be the future perspectives, very technical. And I think that we need to work on crumb rubber specifications for paving applications. We need to have an approval system for these materials, and this could include some physical chemical characterization, simple, not too complicated, but clear, and some rheological testing on model systems. We need to improve performance prediction models, and this, the key part for this is full-scale monitoring. We have several pilot sections in Italy and other countries. Very often what we lack is the information that follows through in time. How did the section behave? What were the problems? Do we have true data? So we really need to work on this. And of course, this needs to be supplemented and supported by performance-related testing. More work needs to be done on terminal blends and dry mixtures. Our group in Torino is working on both. And currently, we're devoting a lot of attention to mixed design issues. Okay, perhaps you can have a good design, let's say a robust mixed design, even by employing a very simple approach. But of course, you need to validate this. Okay, so we're working on that. And finally, as a closure, I think that the two components of pavement engineering and sanitary environmental engineering need to be kept together. This is so important, and it is important within the general concept of sustainability and of green pavements. So with that, I thank you for your attention. You have my reference for future information. Thank you.